So you want to know the product of this looks complicated structure plus 3H2 and platinum. So this is actually a triglyceride. You could look that up, but this is a triglyceride. So what happens when you have this triglyceride and it has an ester right here, an ester right there. So what happens is when you react that with H2, H2 is typically gas unless you pump it into a solution, then it could be aqueous. But anyways, when you react that ester with H2 and platinum, what happens is a reduction. So when you have that, you have a reduction. Okay, reduction. And I'll draw the product for you, all right? And also what you want to realize is you have 6 hydrogens here, okay? 6 hydrogens. So you may wonder what happens to those hydrogens. Well, the 6 hydrogens will turn this double bond, these double bonds that you have marked off, into single bonds, and the 6 hydrogens will go onto each carbon. Okay, so you will have a hydrogen right there, hydrogen right there, hydrogen there, there, and there. All right, and so that those pi bonds will become single sigma bonds. All right, so I'll draw the product for you. Let's see here. And this is actually a unsaturated triglyceride, okay? It has the double bond character. So here is the final product. So what I'll draw is I'll draw it right here. So CH2O. I won't draw the lone pairs on the oxygens just for time's sake, and also just you know where the lone pairs are. So nothing is going to happen to this part of the triglyceride. All right, nothing is going to happen to this part of the triglyceride. All right, so try to keep that in mind. So let's just HCH. Let's do a better job of that. So let's do a better job of that. All right, so we have our C, we have our CH2. It's a big 2 there. And 14. And we have our 14 and CH3. So nothing is going to occur there, okay? Nothing is going to occur there. But let's look at the next structure. CH O and we have C double bonded to O and CH2, and that's 7 of those. 7. And so now, this is where the magic is occurring. You'll have this reduction at this double bond, okay? So you still have that carbon there, and now here is your reduction, okay, to a single bond. All right, and you have your, let me do a better job of this. Let's erase this. Draw that C a little bit better for you. And there we go. Okay, so you have your original hydrogens from the previous structure still there. Nothing happens to those hydrogens, okay? They remain there. But you have 2 new hydrogens because you reduced that to a single bond. So I'll draw the 2 new hydrogens right there, okay, in green. And that is our 2 new hydrogens. And to continue the structure, we have CH2, CH2, and that's 7 of those, and CH3, CH3. Alright, so now let's move on to the last portion of this, where you have your CH2, and that's bonded to oxygen. Again, I am omitting the lone pairs. C, and you have your double bond to O. The platinum in H2 is not strong enough to reduce that carbonyl. Sometimes you'll see mechanisms where the carbonyl actually gets reduced, but right now that does not occur. So whenever you see H2, platinum, and in ester, you know that with double bonds, you know that the double bond will get reduced. Okay, so keep that in mind whenever you're solving problems. All right. So C, and again, it gets reduced to a double bond. C, our oat hydrogens does not change. Okay. All right. And then our new hydrogens. All right. New hydrogens there from the reaction. And we have CH2, and finally, let's scoot this down a little bit. Finally, we have our C, our oat hydrogens from the previous structure, and then our new single bond. All right, new single bond. So we have that there. And like I said, most of these problems are just, I don't want to say memorize, but more or less you do have to memorize the reactant and what's occurring. Okay, so try to remember. For me, I had a mechanism and reaction book that seemed to help out a lot, and I know many people do that as well. All right, and let's continue. Almost done. CH2, and that's 4. And CH3 to end that off. And this is the final structure, okay? Our final structure is this here saturated triglyceride, all right? So let's count up our hydrogens to make sure we have all 6. We have 1, 2, 3, 4, 5, and 6. And we have 6 hydrogens right here, okay? So that's our final product for this reaction of platinum with H2, all right? So this is the final product. And that is what we have.